Am I live? Can you all hear me right now? I'm gonna go to my channel and see if I'm actually live. I am live. Oh, that's kind of cool. Okay, well, yeah, I don't even know if anyone's watching this right now. Well, hello, friends. I'm going to be doing my calculus homework. In context, I am an ASU student and I'm taking Calculus 1 for engineering. So you guys are just going to watch me do my calculus homework for fun, all right? I'm just going to go 2 hours, all right? And if you guys want to study along, go ahead and do that. Or do whatever, watch this in the bathroom or something. I don't care. All right. Oh, you guys can hear me though, right? Or okay. Uh, yeah, okay. Gotcha. Okay. Okay. Well, I just want to see if you can see my live stream. Oh, that's funny. You guys can see my live stream. Well, here we go. So I'm just gonna go to my class. Wait, can you guys hear me? Oh, you guys can hear me, right? Ah, that's right. You guys can. Awesome. All right. Well, where is it? Calculus for Engineering 1. I believe I'm learning the chain rule or um something about derivatives. I, I hope I did not just show my password there, but okay. So, it's gonna go to modules. Oh, what's up, Brooklyn? It's good to have you here. Okay. So yes, I'm seeing a derivatives right now. Yeah, I guess I gotta watch the lecture. So I'll see you all. So the product and quotient rules for differentiation. Okay. Yeah, so we just finished the chain rule, right? We finished the homework. Yeah, okay. Then we got, all right, we're almost at quiz 2. Gosh, why is it so loud? I'm just gonna close that door, bro. There we go. Brothers, am I right? All right. Yeah, we got our assignment there. All right, so awesome. We'll begin now. Product rule for differentiation proof. Quotient rule for differentiation. Derivative of tangent of x. Gotcha. All right, here we go. This is like 1.25.
So we've seen thus far that differentiation respects the operations of addition, subtraction, and also multiplication by constant values. What we'll see in this lesson today is the same cannot be said for multiplication of functions and division of functions. That is, the derivative of a product of functions is not going to be the product of their derivatives, nor the derivative of a quotient of functions is not going to be the quotient of their derivatives. In order to do differentiation of products and quotients of functions, we're going to need to discuss the product rule for differentiation and the quotient rule for differentiation, respectively. Let's look at an example seeing kind of what goes wrong with multiplication and division of differentiable functions. Consider the function y equals x squared.
Hold on, I'm just gonna.
Let's look at an example seeing kind of what goes wrong with multiplication and division of differentiable functions. Consider the function y equals x squared. Now this is a function that we can calculate the derivative using the power rule. So y prime is going to be given by 2x. Now we can also write y equals x squared as a product of two functions, namely the product of x times x. Now looking at the derivative of just f of x equals x, calculating f
Lower the volume here, bro.
Times x. Now looking at the derivative of just f of x equals x, calculating f prime here, we'll get 1. And notice what happens here. If we look at the product of
Hmm. Oh, so I guess would it get something like y prime equals 1 times 1 if we could do the product ruler. I mean, if you could do multiplication for derivatives. But yeah, 1 times 1 is not 2x, so it makes sense that it doesn't work.
Of the derivative of x and the derivative of x, this will become 1 times 1,
Yeah.
which is not equal to the actual derivative of the function y equals x squared.
Mm.
So we see here right off the bat that, in fact, the derivative of a product is not equal to the product of the derivatives in generality. So now
the derivative of a product, yeah, so we're saying like the derivative of y, no, y equals x squared, or that's y equals x times x. Y prime is not the derivative of x times the derivative of x, because that would be the derivative of one. That would be 1 times 1, which is not 2x. Yeah, that makes sense.
let's consider a quotient of differentiable
All right, I'm just gonna go
functions
back.
is not going to.
All right, so
So we've seen thus far that differentiation respects the operations of addition, subtraction, and also multiplication by constant values.
Okay.
What we'll see in this lesson today is the same cannot be said for multiplication of functions and division of functions. That is, the derivative of a product of functions is not going to be the product of their derivatives, nor the derivative of a quotient of functions is not going to be the quotient of their derivatives.
the derivative of a product is not going to be the product of the derivative. Okay, I guess it makes sense. Yeah.
Be said for multiplication of functions and division of functions. That is, the derivative of a product of functions is not going to be the product of their derivatives.
The derivative of a product of functions. The derivative of a product of functions. Yeah, a product of functions. X times x, y times y. Right, anything. Is not going to be the product of their derivatives.
Nor the derivative of a quotient of functions is not going to be the quotient of their derivatives. In order to do differentiation of products and quotients of functions, we're going to need to discuss the product rule for differentiation and the quotient rule for differentiation, respectively.
Gotcha.
So, let's look at an example seeing kind of what goes wrong with multiplication and division of differentiable functions. Consider the function y equals x squared. Now, this is a function that we can calculate the derivative using the power rule. So y prime is going to be given by 2x.
Yes.
Now, we can also write y equals x squared as a product of two functions, namely the product of x times x.
Yeah.
Now, looking at the derivative of just f of x equals x, calculating f prime here, we'll get 1. And notice what happens here. If we look at the product of the derivative of x and the derivative of x, this will become 1 times 1, which is not equal to the actual derivative of the function y equals x squared. So we see here right off the bat that, in fact, the derivative of a product is not equal to the product of the derivatives in generality. So now let's consider a quotient of differentiable functions.
All right. The derivative of a product is not the product of the derivative. I guess that makes sense.
How about the function h of t equals t cubed over 2 times t?
Okay.
Now, provided that t is not equal to 0, we can simplify our h of t function by canceling some factors of t and rewrite h of t as t squared over 2. Cancel a factor of t in the numerator and denominator. Now, using our power rule for differentiation along with the constant multiple rule for differentiation, we can calculate the derivative of h. The factor of 1/2 comes along for the ride, and the derivative of t squared, according to the power rule, is going to be 2t.
Yes.
Now, simplifying this, we'll get that h prime of t is equal to just t. Now,
Yeah.
remember that h of t was originally the quotient
Oh, yeah. A derivative
of the functions t cubed and 2t. Now, looking at the derivative, now simplifying this, we'll get that h prime of t is equal to just t. Now, remember that h of t was originally the quotient of the functions t cubed and 2t. Now, looking at the derivative of our numerator function, derivative of t cubed is going to be 3t squared, and the derivative of 2t is going to be 2. Both of these we get from the power rule for differentiation. Now, if we look at the quotient of the derivatives here, what are we going to get? Numerator derivative is given by 3t squared. Denominator derivative is given by 2. And this will simplify to 3.
Oh, yeah, so this is the wrong version. Yeah, you don't just... Yeah, here we have... Well, let's see how to think of this. Yeah, so the way I see it is that we have a function, a quotient, and then we apply the derivative of a quotient. Applying the derivative of a quotient is not equal to a quotient of the derivatives. Yeah, here we have the derivative of t cubed, the numerator, and then 2t, the denominator. You can't just do the quotient of the derivatives because you won't get t. Or was this the wrong one? Hold on. H prime of t. Hold on. Oh yeah, right. He simplified this in a way that we did not have, that we could use the rules that we already knew. H prime of t, he simplified it so that we could use the constant multiple rule. Yeah, so now we only have, so this, h of t equals to 1/2 times t squared. Right, just another way of seeing it. And then we have h prime of t. Oh, wait, what the heck? Oh, yeah, right. Yeah, 1/2 is a product, so you don't do anything with it. And then you do the derivative of t squared, and that's 2t. Right, and this is a correct way to do it. But doing the quotient of the derivatives is incorrect because we don't get t. We get something like 3t squared over 2.
3t squared over 2. But notice here, once again, we get something different
than t
from the actual derivative of our function, which we calculated using the power rule.
Gotcha.
So here we have an example where the derivative of a quotient of functions does not equal the quotient of their respective derivatives.
Yeah. The derivative of a quotient of functions does not equal the quotient of their derivatives. Of whose derivatives? The function's derivative. Here we have t cubed, that's a function, and then we have 2t, that's a function. Here we have a quotient, and the derivative of the quotient is not the quotient of the derivative of t cubed over the derivative of 2t.
Function, which we calculate respective derivatives.
I see.
So, what have we just seen here? The derivative of a product is not necessarily the product of the derivatives, and the derivative of a quotient is not necessarily the quotient of the derivatives.
It's not the quotient of the derivatives. Gotcha. Okay.
So what is going to solve this issue for us? Well, both the product and quotient rules for differentiation. So let's take a look at these rules.
I love it. Yeah. In part 1, you see why these rules don't work. And then I'm guessing in part 2 and 3, we see what are these rules. Hold on. Yeah. I think I'll have to look at part 2 and part 3. 11 minutes, and that's 9. Yeah, so that's like 20 minutes. All right. Let's get this quickly. Oh, what's up? Oh, dude, my hair looks ugly, bro. Oh my gosh, dude. I just hit something. There we go. Oh, yeah, that doesn't look good as well. I mean, I went swimming this morning. I swam for 45 minutes. It was a good exercise, but now my hair is all sticky and stuff, so that's not cool. Hey, how do I look? Do I look good? I guess it's fine. I'm not. Gosh, bro, what's going on here? Yeah, I didn't really apply a lot of shampoo or something. Whatever. Well, let's go back. Why am I wasting time? All right, here we go. Hold on, bro. Should I turn off the light or something? There we go. Well, that's much better.
So let's first take a look at differentiating products of functions. We saw previously that the derivative of a product of functions is not necessarily the product of their derivatives. We're going to need to use the product rule for differentiation. So let's see what the product rule is all about.
Gotcha.
Now, how will we take a derivative of a product of two differentiable functions? Well, if f and g are both differentiable functions, and we want to take the derivative with respect to x of the product f of x times g of x, we can calculate this derivative as follows. F of x times the derivative with respect to x of the product f of x times g of x. We can calculate this derivative as follows. F of x times the derivative with respect to x of g of x plus g of x times the derivative with respect to x of f of x.
So f of x times the derivative of g of x plus g of x times the derivative of f of x. I see. Hold on, okay. Okay, I see.
Now, if we think about the order of how we do our multiplication here, where f of x is the first function multiplied and g of x is the second function multiplied, we can remember the product rule as follows. First times derivative of the second plus
second times derivative of the first.
Second times derivative of the first.
All right, I'm pretty bothered by the fact that I'm watching a video from ASU. I don't know if this is gonna be copyright. I just want to ask ChatGPT real quickly. Is it bad if I am live streaming me watching videos from ASU? Is this copyright? Oh, that's not that good. Well, here's what we're gonna do. I'm gonna stop sharing, and you guys are just gonna watch me listen to the video then, because I don't want to face any problems. Okay. You. Oh yeah, hold on. We'll have x times x prime plus x prime times x. Right. So x plus x. Nice. I see. Yes, sir. All right. We got to go faster. Hold on. We have f prime of x For f of x equals x squared sine of x. All right. Well, I mean, yeah. Let's just do this, and then we'll just skip this part quickly. Where are we? We have f of x equals x squared sine of x. So f prime of x is going to be, it's going to equal f of x, so x squared, times the derivative of sine of x prime, plus sine of x times the derivative of x squared. So here we get x squared times cosine, cosine of x. Oh, darn it. A cosine of x plus sine of x times 2x. Yeah, so yeah, this is pretty easy. Yeah, x squared cosine of x plus 2x sine of x. Yeah, I don't know if I can simplify that more. All right, hold on. All right, let's go. All right, hold on. Copyright. Um, okay. What? Looking depressed? Dude, I'm not looking depressed. What are you talking about? Anyway, where was I? Here. All right. All right. I guess you guys just see my a big fat face. All right, let's do this ourselves. A company sells fashionable hats. The number of hats it sells T months after being in business, yeah, so T is time, is given by, we have Q of T equals 500. And in fact, yeah, I mean, I guys, I'm pretty sure you guys can see this, right? There we go. All right, so Q of T equals 500 minus T minus 100 squared over 500. So Q of T is what? Number of hats it sells after T months. Gotcha. The price charged per hat, T months after being in business. Oh, gotcha. Okay. And we have P of T equals 30 minus T over 20. Okay. So Q of T is number of hats it sells after T months, and P of T is price charged for a hat after T months, I'm guessing. How is company's revenue from selling hats changing exactly 4 months after being in business? So T is equal to 4. Hint, revenue equals the number of items sold times price per item. Sure. Okay. Whoops. No. Hold on. So, our first task is to determine the revenue function for a fashionable hat company. We can calculate the revenue made during month T by taking the product of the number of hats sold and the hat price functions. Huh. Let's see. How's a company's revenue from selling it? I mean, I think this looks easy. I'm just like trying to understand. Changing 4 months after being in business. Okay. Yeah, so T equals 4. Okay. Oh, gotcha. All right. So, yeah, we need to know the number of items sold after time T, after months T, and we need to know the price per item. So we know, oh, let's see, number of hats it sells after being in business. The number of hats it sells after being in business. Gotcha. Okay. T months after being in business. All right. But where do the derivatives come in here? We're not calculating a rate or anything. Hold on, I'm just gonna take the audio off so no copyright. What? Mm, differentiate, but we're not calculating a rate or anything, are we? Number of hats it sells after being in business. Price charged per hat. I mean, this. I feel really dumb right now. I don't know what I'm doing right now. Okay, hold on. So we have determine revenue function. Calculate the revenue made during months T by taking the product of the number of hats sold and the hat price functions. Okay. So we just plug in T, I'm guessing. I mean, yeah, but where do derivatives come? To find the revenue, to find how the revenue is changing in exactly 4 months after the company has been in business, we will have to differentiate R. And what is R? I don't see any R here. Can you guys see it? Huh. Q of T and P of T, but I don't see any R though. Oh, I'm stupid. Is it the revenue? All right, I'm just gonna watch this guy do it. Can you hear me though? I took all my volume off. Can you guys hear me? Oh, you guys can hear me. It's funny watching myself. Okay. All right, well, let's do this. So, um, during months T by taking the product of the number of hats sold per hat price. So R of T, what is this equal to? We have Q of T times P of T. Sure. Right. Okay. All right. So I mean, we don't have any derivatives here. Yeah. All right. So Q of T. So after 4 months, so we have Q of 4 equals 500 minus 4 in yeah. Right. My bad. 100 squared. We got like a difference of squares right there. Over 500. Okay. So this equals to so should we go ahead and square it? All right. Well, let's do that. Oh, wait, no, but do you use a calculator for this? Probably. So we have, okay, 500 minus, all right, 4 minus 96. We got negative 96 squared. Yeah, regardless, is going to be positive. So 96 squared. 9,216. Okay. 9,216 over 500. In fact, I was going to pull up Desmos right here. We got 9,216 over 500. Dude, what are you doing? Why am I getting decimal places, though? 500. Oh my goodness, guys. We're not thinking at all here. We still got to multiply this thing. Come on, let's lock in. So we also have P of 4 equals 30 minus 4 over 20. This also equals 30. Wait, 4 over 20 is what, like 1/5 or something? Yeah, minus 1/5. And 30 is what? 30 is 1/55, I think. So we got 1/55 minus 1/5. We got 1/49, right? Yeah, I think I got that right. 30 times 5 is 150. Cool. So multiplying them together, and that's going to be our revenue, I think, R of T. So R of T is going to be 500. All right. I'm not going to square the 4 minus 100. So 100. Up to this point, I think I'm just talking to myself. I don't know if you guys understand what I'm doing, but it's fine. I mean, you guys are just watching me do homework, right? 149 over 5. 149 over 5. Gotcha. Yeah, I really don't know how I'm going to simplify that. I think you're just going to. Yeah, cool. You're gonna. To find how the revenue is changing exactly 4 months after the company has been in business, we have to differentiate R. 4 months. The revenue. Why? Revenue is the number of items sold times the price per item. And we got that here. Q of T is the number of items sold after 4 months. And P of T is the price per item after 4 months as well, I believe, right? Yeah. So to find the how the revenue is changing, right? And that's a rate. So we differentiate that. So we have R of T prime equals. Yeah, no, I'm not gonna do that, dude. Oh, product rule. Oh, that's even worse. No, it's fine. I think I will get something like Q of T times P prime of T plus P of T times Q prime of T. It's gonna and 1 over 500. How do you do that? Oh, you just calculated Q of T. Oh, Q of T equals. What do you do here? Oh, you divided by 500, right? 1 over 500. 1 over 500 times 1. What are we doing here? Do you guys see it? I don't. Oh, no, we just did the derivative. Right. So we get, what do we get? Let's see. So 500, that becomes 0, I think, since that's a constant. Right, 0. That's why we don't see it. Minus, I see it now. Minus, we take out the fraction. We have 1 over 500. That's a constant, so we don't do anything with it. A constant multiplying the function. And then times 2 times t minus 100. Wait, but we have to do the chain rule, though. Why didn't we do the chain rule? 2 times t minus 100. And is it going to be like times the derivative of t minus 100 or something? Oh my goodness, bro. T minus 100. I swear, I think this guy got it wrong, but oh yeah, okay, whatever. Minus negative 2, right? Oh wait, what happened here? How do we get it to? Oh yeah, 2 to 50, right? And then we got to do the derivative of 30 minus t over 20, and we get negative 1 over 20. Yeah, and then you just multiply all of that together, and then evaluate it at t equals 4. We get that 12.6. Awesome. Okay, I think I understand it. Yeah. And and here we see the quotient rule. Okay. It's a little sad in here. Should I turn on the light? Is that better? I don't know. Okay. Okay. Uh. Oh. The, that's not good. Oh. All right. What's going on in the comments? What are you doing there? Is nobody else than me? We're studying how to study economics. Cool. Yeah. I don't know if I've met you before. I have a good time with economics. My mom studied economics, and she's told me about how it's also math heavy. So, good luck, dude. Good luck. Mm. We got part three. It's 9 minutes. Yeah, no, it's fine. All right. And what's the quotient rule? Quotient rule. Oh, let's go do this. Spell that right. So we have in calculus, the quotient rule is a method of finding the derivative of a function. That is the ratio of two differentiable functions. Let's go, dude. Let h of x equal f of x over g of x, where both f and g are differentiable, and g of x is not zero, or else the function will be undefined. The quotient rule states that the derivative of h of x is f prime of x times g of x minus f of x times g prime of x, all over g of x squared. What does that mean? In the product rule, we had f of x times g prime of x. So, all right, I'll just watch the video quickly. Hopefully, we don't get any copyright. Yeah. If f and g are differentiable functions and g of x is not zero, we have g of x times the derivative of f of x minus f of x times the derivative of g of x. Now, how does this relate to the product rule? Because the product rule was the derivative of f of x times g of x. That's f of x, the f of x times the derivative. Okay, whatever. Just memorize that. I mean, there's probably like a proof. I think high function. F as the high function recording its position on the numerator. D, okay. Low, D high. Low, D high, high minus high, D low. Right. Yeah, so here we'd have, let's see, we have h of t. H of t equals t cubed over 2t. So we would have, all right, let's just write that down. T cubed over 2t. This equals, so low d high. We have, so g of x times the derivative of f of x, so that's 3t minus high d low. So we have t cubed minus the derivative of 2t, which is simply 2. All of this is over g of x squared. We get 4t squared. Well, yeah, I don't know if I can simplify. Oh, no, I can't simplify. So 2t times 3t is 6t squared. Oh, okay. Minus t cubed minus 2 all over 4t squared. Yeah. Let's see. What else we got? What do you get? Whoa, what happened to the 2? The derivative of 2t. Oh, bro, what are we doing here? This is multiplication. Here times 2t. Finally, so 6t squared minus t cubed, or 2t cubed. 2t cubed. Awesome. And then we can factor now. 2t cubed over 4t squared. So this is 6 over 4 is what? 3 over 2? Yeah, that's all you can simplify. We have hold on. I must take 4 out of everything. Oh my gosh, dude, the dog. Oh, bear times. You can't do that, right? Oh my goodness, dude, what am I doing? Simple fractions. Yeah, how do you simplify this? Oh, wait, hold on. No, it's easier than we think. Hold on. Why did you get cubed right there and we have squared? 2t times. Oh, hold on. Is it 3t squared? Yup, the 3t squared. Well, I always forget that. So if that's the case, then we have 4t cubed over 4t squared. Wait, if I have t, no. Oh my gosh, dude. Yeah, no, you don't subtract the t cubed, obviously. And then we have 4t. We have 4t. Why did he get t? 4t cubed over 4t squared. The 4 cancel. Oh, right. The 4 cancel. Okay. So now we have t. Let's go. First try, bro. All right, now let's try that. We have f of x equals x over cosine of x. This equals wow, I've not even begun my homework. Okay, in 6 minutes we'll begin on the homework. Let's just finish this. So we have cosine of x times x prime minus x times cosine of x prime over cosine of x squared. I think so. Hopefully we didn't get that wrong. So we have cosine of x times 1, which is whatever, minus x, or okay, fine, plus x sine of x, because the derivative of cosine of x is negative sine of x. And this is all over, what's cosine of x squared? Is there like an identity for that? Yeah, a cosine of x squared. It doesn't matter. Cosine of x squared. Ooh, I can't talk. All right, and final question we have f of x equals sine of x, sine of x plus 4x. Guys, how does my hair look? Oh my gosh, bro. Why is it I swear, guys, I took a shower. I don't know why my hair is like this. Oh, a cosine of x squared equals 1 plus 2 cosine of x over 2. Interesting. Oh, guys, my throat. Okay. Thank you. I don't think I need to simplify more for this a question, but if I ever get a question like that, I think I'll use that. Thank you. Anyways, so we have plus 4x, x cubed minus 9x squared plus 2. This equals, so we have g of x. So, oh wait, there you go, yeah. Oh, wait, pause. Pull the brakes, bro. Hold on. G of x is a polynomial. Okay, yeah. I think we treat it like that, right? So we have x cubed minus 9x squared plus 2. That's literally g of x times, we need f prime of x. So we have the derivative of sine of x plus 4x, just minus f of x, right? No, hold on. Low d high, high d low. Right, oh yeah, f of x. Sine of x plus 4x times the derivative of x cubed minus 9x squared plus 2. And this is all over x cubed minus 9x squared plus 2. squared. Okay, that's going to be a lot of algebra there, but let's do it. Let's do it. You guys are with me, right? We're doing this algebra together, right? Hold on. All right. Here, in fact, you guys, here, there you go. Here, so we have, what do we got? Yeah, well, that's gonna be tough to simplify. Hold on. So we have x cubed plus 9x squared plus 2. No, I was kidding. Yep, there's no chance we're gonna do that. No chance. Absolutely no chance. I think that's gonna be a little tough to do. It's fine. How does this guy do it? Oh yeah, I don't simplify. Perfect. All right. Well, I think that's all we need to learn. Now we can go on to do the homework. Yeah. Oh, let's do this, guys. We still got like an hour and 15 minutes left, so we're not even halfway. Yeah, we go 46 minutes on the live stream. Wow. Okay. Do I know you guys? San? Yeah. I'm not sure I know you. Interesting. Okay. Well, thanks for being here, guys. I didn't know how to get with this many comments. It's kind of cool. Okay, hold on. Yeah, I don't think I need that. Let's keep that there. Not for reference, but it's fine. All right, well, let's do this. I mean, here we're just learning rules. Not very conceptually deep. Okay. Homework started. Let's go, guys. So let's close that. Find the derivative of f of x equals x to the power of 6 times cosine of x. Well, we got a product. So we apply the product rule. That's going to be, what's a product rule? Product rule f of x times g prime of x. There we go. So we got f prime of x equals x to the power of 6 times negative sine of x plus cosine of x. Bro. Cosine times the derivative of f of x. So that's 6x. Simplifying, we get x to, well, can't talk today. X to the power of 6. All right, yeah, just do negative. Negative x to the power of 6 sine of x plus 6x cosine of x. Yeah, I don't know if I can simplify anymore. X to the power of 6. Oh, whoops, no. Negative x to the power of 6 sine of x plus 6x cosine of x. Yeah. I think that's right. What? Oh, wow, guys. This is embarrassing. Hold on. What do we get wrong? All right. This is the first question. Okay. Let's see. We got 6x. Cosine of x. Is the error obvious? Or, I mean, huh. All right. Let's do this again. So the product rule, we got f of x times g prime of x. And g prime of x is the derivative of cosine of x, which is negative sine of x, plus g of x times the derivative. Oh my goodness. We did it again. We did it again, guys. No, this is to the power of 5. There we go. Yup. Okay. All right. We know that we're not getting that wrong again. Find the derivative of f of x. Woo. F of x equals, okay, hold on. So we have f of x equals 2 over 7x plus 2. and we need to find the derivative. So now we apply the quotient rule. So this equals, yeah, g of x times derivative of 2 is nothing, right? Is that 0? Derivative of 2, yeah, I think, wait. I mean, this is a product though, and it's a constant, but you're not adding it. Derivative of, yeah, no, 0. So, and then we have, here, I'm just gonna, I'll put you guys over here. Whoops. Here's the. So now we do low d high, high d low. So 2, the derivative of 7x plus 2 over 7x plus 2, all of that squared. This equals 2 times, all right, derivative of 7x plus 2 is simply 7. So 2 times 7 over, all right, a 7x plus 2. Well, we can do it first. This equals 7x plus 2 times 7x plus 2. So, all right, 7x, we got 49x squared plus 14x plus 14x plus 4. This equals to 49x squared plus 28x plus 4. So, yeah, we got like a huge polynomial. All right, yeah, no, just a quadratic, 48x plus 4. So, in the end, we got like 14 over 49x squared plus 28x plus 4. I don't think we can simplify. We'll just go. Oh, wait, hold on. Should we do 2 binomials? Yeah, no, I don't think so. I think we're good. If we get it wrong, we'll recheck. And if nothing seems wrong, I guess we'll do the 2 binomials. Plus 28x plus 4. Oh, all right. What do we get wrong? Hold on. So we have g prime of x. G prime, okay, we have 7x plus 2 times the derivative of 2, which is 0. And something times 0 is 0. Oh, negative. Hold on. Is it just a negative that we got wrong? Yep. Gotcha. Cool. All right. Well, now we let. How's the comment section doing? All right. We're cooking, right? Cool. No. I'm sorry. We can't get distracted. We still got an hour and 10 minutes left. We got to do this. We have, how many problems do we have? We have 15 problems and we only got 2. Uh-oh. All right. We got f of x equals. There we go. Cool. F of x equals 2x minus 7x to the power of 3 times 5 plus square root of x. Find f prime of x. Let's see. So we got, how do we do this? Well, this is a product, so we do the product rule. All right, what's the product rule? We got f of x times g prime of x plus g of x times f prime of x. There we go. So we have what? So f of x, we have 2x minus 7x cubed times the derivative of g prime of x. Just do it right away. We have, all right, derivative of 5 is 0 plus the derivative. Okay, so square root of x is x 1/2. So the derivative of that is going to be 1/2 x times negative 1/2 to the power of negative 1/2. My bad. So we have 1/2 x. I hope I did this right. I'm a little skeptic because of that 5, but no. I mean, I'm following everything well. plus g prime of x, which is 5 plus the square root of x times f prime of x, which is, oh, I'm running out of space, which is 2 minus 14x to the power of 2, I think. 3. Oh, wait, hold on. No. 21. Not 14, 21. 21x to the power of 2. Gotcha. Yes, that looks right. And wait, is there like a video? Nice. No, I was not planning to watch the video. I'm not lazy like that. Let's see. No, I think we got to simplify. All right. Yeah, it doesn't seem too bad. Oh, wait, but we got that. Okay. Let's. I'm sorry for pointing at you guys. I think that's a little rude. I should not have done that. Yeah, no, okay. I think I'll plug this in. They're not looking for algebra, but just a understanding of the rules. I shouldn't take this long anyway on each problem. Negative 1/2 plus 5 plus square root of x. And this is 2 minus 21x to the power of 2. Okay, let's continue. Oh, guys, I'm feeling the urge to like stand up or something, but no, we gotta keep going. F of x equals cosine of x minus 2 tangent of x. Y'all are holding me accountable, right? You're watching me focus, and you'll tell me that not to get distracted, right, guys? All right, f prime of x. Oh, wait, hold on. We got where's the product? I mean, we got 2 tangent of x. Does that count as yeah, that's obviously a product. So we do cosine. Oh, wait, hold on. So the derivative of cosine of x is negative sine of x minus, and then we do the product rule. So we do 2 times, wait, what's the derivative of tangent? I mean, tangent is what? Sine over cosine? If tangent is sine over cosine, then, oh, bro, we got another quotient. Sine over cosine. So the derivative of that is going to be, so we do the quotient rule again. I mean, I could just search it up, but this way is cooler. We got cosine times the derivative of sine, which is cosine, minus high d low, low d high d low, sine times the derivative of cosine, which is negative sine. So that's just plus sine times sine, over cosine squared. Gotcha. So in the end, this is cosine squared plus sine squared over cosine squared. Oh yeah, addition, so you can't subtract anything. But that's what we get. What do we get if we do derivative of tangent? Yeah, that's what I'm doing. Secant squared. Yeah, no, yeah, I don't know if I could have done that myself. Secant squared. All right, I guess I'll have to remember that. Hopefully there's a proof around that somewhere. Oh, look, it's Be Real time, guys. We're gonna, I'm gonna take you guys a picture, okay? I'll be real. Let's go, guys. You guys looked very good in the picture. I think like better than me. I didn't look very good in the picture, but it's fine. I'm not gonna retake that because it looks like I'm upset. No, I was kidding. What am I saying, guys? Whatever. All right, secant squared of x. Let's continue. We're just yapping over here. All right, 2 times secant squared of x. Yeah, derivative of g prime of x minus. Oh, guys, we're running out of space. What's going on over there? Where was I? 2 times g prime of x minus g of x, that is tangent of x, times the derivative of 2, which is 0. So we subtract nothing because 0 times anything is 0. Okay. So I hope I'm doing things right over here. Minus 2 secant squared of x. Let's do that. Negative sine of x minus secant squared of x. Okay. Oh, all right. It looks like we did that correct. Let's do it. How long do we got? We're 1 hour in. Whoa. Okay. 1 hour in. We got an hour left. Literally an hour left, guys. Okay. We're doing good. Nice. Okay. That's cool. Okay. We can close that. Yeah. How did this a person do it? Um. Oh, she did do the sine of x. Oh, okay. I was correct about that. Um. Hold on. Wait, why did she do? Oh. How did I get this right? I don't think I. Oh, no, I did. I did. My bad. How did she get? Yeah, I did that, and yeah, I got exactly that. Why is that 1? Oh, that's an identity, I'm guessing. Cosine of x, cosine squared of x plus sine of x squared, cosine squared of x plus sine squared of x is 1. 1 over cosine squared of x. And I'm guessing that's equal to secant. Secant, oh, wait, hold on. Oh, so secant of x equals 1 over cosine of x. Therefore, 1 over cosine squared of x is secant squared of x. Gotcha. Okay. I see. Cool. Yeah, but I mean, I think we did that all similar. The only thing we did different is that I had no idea that cosine of x plus cosine squared of x plus sine squared of x equal to 1, and thus that we could derive secant from that. I just searched that up, but we got the same thing. All right, let's continue. We have f of t equals why am I so distracted? Well, t squared plus 6t plus 4. Oh, is it because I'm talking to the camera? I should just be quiet. All right, guys. So I'm just gonna stop talking. I think I'm getting a little too distracted. I know it's fun, but I just gotta lock in. So, t plus 6. There we go. Awesome. What happened, bro?
I'm just gonna be in here the entire time.
You know I'm streaming, right? Actually, look. I mean, guys,
Okay.
aku tingin malu po. Thanks, bro. Thanks, Lucas. Okay, we're back. Now, why is this? Oh, yeah. Times g prime of x plus g of x times f prime of x, f of x times -2, -14, -3, -15. What did we get wrong? Mm. T. Yeah, 7 times -2 is -14. And 5 times -3 is -15. Subtract 1, -3, -4. Yeah, what's wrong? So we got a product. So f of x 9 times these radical plus. I think we got like a minor error. I don't see what though. 6, 4, t6. Oh, yep. 2t. Yep. Okay, let's keep going. We got 10 questions left. Let's do this. So now we have Jeez. Oh. Load the There we go. Bear escaped. Uh, negative x 2 times negative x to the power of 1. 2. That. And this is going to be plus square plus plus and 4. Oh, whoops. Simplify here. All right. What are two numbers that add to 4 and multiply to 1? 3. Yeah, no. That's tough, isn't it? Or is it easy? Add to 4. You know, I don't know. 2, 1, 3. Yeah, 4 and 0. Yeah. Okay. Yeah. Let's just simplify. I hope I did this right. Okay. Let's see. 4x minus. Oh, wait, hold on. So we got 8x plus. Yeah, I think this is correct. So, replace, right? Yeah, it's simple. 16. So 32 over 2 to the power 4 is 16. So 16 plus 16 plus 4. So 32, 32, 36. This equals to, well, 16 over 18. 8 over 9. 8 over 9. Okay, I think that's right. Oh, that's not good. Let's see. What did we get wrong? Oh, we applied the product rule. Not kidding. Yeah, no, we didn't do that. Let's see. Oh. All right. Wow. I can't believe we got that wrong. Whoa. No way, dude. That was not really smart. Come on, Lodi high minus high. Dude, how did we do that? Okay, all right, it's fine. No. This is good. This is good. Just gotta pay attention. So, negative 2x. Huh. Wait, no, that's not right as well. All right. Yeah. There you go. This is good. Okay. So we have 4 minus x squared, 2 plus x squared. There we go. Okay. That makes much more sense. There we go. All right. I think we were pretty close. This is minus 2x. That's right. Yes. So now we got all right. Yeah. So we'll have to do this. Hold on. Is that right? We got negative 4x minus 2x cubed. 4 minus 2x cubed. What? 4. I'll put like 2t. That's equal to negative 8x. Oh wait, hold on. That's supposed to happen. Let's yeah. That right? Yeah. There you go. Then we have 2 16 minus 2 38 negative 4. Sorry, 4 times 8 is 32. So negative 48 over 16 plus 4 times 4. 16 plus 4, 36. 24. Got 18. Got 9. 12. Over 3. Got 4. We got 3. Negative 4/3. All right. Oh, that hurts. Calculus 1. This is a calculus 1 right now. Yeah, I'm just learning derivatives. Calculus 2, I think it's like integration. Yeah. Okay. Oh, we're not done though. It's 1 hour, 19 minutes. We got 40 minutes to finish 9 problems. Oh, dude, what is so hard about this? What's going on? Hold on. So we have low derivative of 4 minus x squared, right? Minus high d low prime. 2 plus x squared to the power of 2. Right. All right. Derivative of 4 minus x squared is simply negative 2x, right? Yeah. Minus oh, we did it again. 4 minus x squared. Come on. There we go. That looks about right now. Okay. Minus. All right. So minus. So 4 times. So we have 8x plus 2x to the power of 3. And solving gives us equals anything coming out? Oh, nothing left. Okay, that's it. So we'll just have to use this. Huh, that's weird. Negative 2x, yeah. Yeah, it's not 2x, right? Negative 2x. 4x plus 8x squared. Interesting. Okay, yeah, but that's not what we have. Negative 12x. So we have 2 negative 24 over, what do you have? A 36. So we got 12, 18, we got 6, and we got 9. And we have 2 and 3. Negative 2/3. Finally, okay. Now we can move on. And how do you do it? Yeah. Gotcha. Yes, sir. Uh-huh. Yeah. I mean, yeah. Incredibly simple. I don't know why we took so long, but it was good. Just make sure to check your work, guys. Okay, let's continue. Oh, I think I need to go to the bathroom. Okay, not yet. Let's finish this and then we can go to the bathroom. I can go to the bathroom. I don't know why I said we. Unless you guys need to go to the bathroom, so you guys can go now. So we have square root of x minus 3 over square root of x. Oh, we got like a conjugate or something. Oh, guys, watch this. So we got like a neat trick. Multiply by the conjugate. I think it's going to be plus. Oh, wait, hold on. Is it an appropriate time to apply the conjugate? Should we do the conjugate or should we just do the quotient rule? I can't tell. Yeah, no. Let's do the quotient rule, I think. So we have prime of x equals x plus 3 times the derivative. I'm running out of breath. Math takes up a lot of breath. X prime minus. Minus what? Low. Okay, please lock in. Low. All right, I'm just gonna go to the bathroom. I'll be right back. All right. Hope you guys didn't hear me. So we have minus high d low x. Whoops. Times the derivative. Here, I'm just gonna close that door. You won't distract me. All right, I'm gonna lock it. Turn off the light. No. What am I doing? Come on, let's go. Yeah, let's go. Turn off the light, dude. Squared. Awesome. So we got. All right, that's it. Let's lock in. So, bro. Mm. Square x. Okay. Hey guys, what's 3 plus 3? I was kidding. We got that. I was confused for a second, but okay. Yeah, unless we can't simplify anymore, I think this is good. But dude, I'm going incredibly slow. What math subjects are you guys seeing right now? What's the audience like in here? Are you guys seeing algebra or calculus, a pre-calculus, a geometry? Okay. That's awesome, guys. Here, I'll see the comments if anyone said anything. Times 1/2 x to the power of negative 1/2. All of this over. Could I have simplified? Okay, maybe I could have, but it's a little bit hard to simplify. 6. Whoops. Um, 5. Okay. Yeah, we'll just 5. 5. Yeah, I don't know if I can simplify that. I don't think so. 5. Okay, we got 14. 5. But that's it, I think. Oh, wow. We got that correct. Tough. Wow, dude, we're halfway through the homework. Oh, I'm a little tired. Oh, hi, Cyan. All right, we still got 29 more minutes. Oh, all right, guys. I'm gonna like get back for a second. What's going on here? Oh, that's funny. I'm watching myself. Oh. Okay. Well, let's do this. All right. All right. We're back. So, just turn the page. Fresh new start. Um. So we. FX. Prime of x plus cosine. Derivative of sine of x plus cosine of x. Yeah, well, that's simply right. Yeah. Oh. Yeah. Oh, I think I need a speech therapy. I'm not really being clear. All right. Derivative negative 12. Okay. What am I doing? All right. Now 12 cosine of x. Oops. Gotcha. Here. Awesome. Okay. So, yeah. Plus 12. Cosine of x. Awesome, bro. Okay. Negative 24 cosine of x. Oh, awesome. Okay. Negative of pi thirds. And that's going to be, hold on. So if we imagine that the unit circle, cosine of pi thirds. Let's see. So we got pi halves in the middle. Oh yeah, cosine is the x-axis. So I imagine pi thirds omega pi is 6, pi fourths, and pi thirds. There you go. So that's going to be 1/2. No, hold on. Which is the biggest? 1/2, I think. I think this is a 1/2. Oh, hold on, bro. Wait. And that's simply 12. Whoa. My derivative was not correct, but plugging this in was? Oh, what? Okay. Yeah, negative 12x cosine of x minus 12 cosine of x. Oh, wait, 12x. Oh, what am I doing? Oh, I'm sorry, dude. Gotcha. Interesting, dude. Okay, hold on. All right, whatever. Wait, how did I get that right? Because this is completely wrong then. Oh, wait. Negative 12x. Yeah, my bad. There we go. Negative 12x right here. Forgot that. So we have 12x right here, and we also have 12x right here. So that means negative 12x cosine of x minus my bad. Plus minus negative 12x cosine of x. We got all right. Yep. We forgot the x. That's we also got that wrong as what's going on, bro? Hold on. So negative 24x cosine of x. What's going on? Negative 24x cosine of x. Bro, it's like something to do with a negative or something. I mean, I actually thought that was going to be right. Oh my goodness, dude, it's 10:51. Long. We have 22 minutes. Oh, what's this? Negatives. Oh yeah. Okay. I guess we can factor. All right. Let's try that. Yeah, negative 12x. We have cosine of x plus sine of x minus sine of x. Oh wait, no, I'm sorry. No. Sorry, we factored negative 12x. So yeah, cosine of x minus sine of x plus sine of x minus cosine of x. So here we get negative 12x cosine of x. Oh, whoa, interesting. Cosine. Wait, did he do this right? No, my bad. This is plus cosine of x because. Okay, yeah. So cosine. So we have 2 cosine of x. Yeah, that's all we have. Oh, gotcha. 2 cosine of x. Hey, dude, thank you very much. I think this should be right. So 48, I think. As well. Oh, hold on. What happened? Oh, wait, no. I think the 24 was good then. Because we did add that up. Oh, whoa, okay. 12 sine of x plus cosine of x. Okay. Okay, hold on. I guess that would be right, but I think the negative 12x. No, I don't think I have a 12 anywhere. Huh. That's odd, dude. All right, okay. Well, let's see. I may be missing something you're trying to tell me. So if I am, forgive me. Let's see. So we have 12x, which is negative 12x times that prime plus that times negative 12x prime. Okay. So we have negative 12x cosine of x. The derivative of cosine of x is negative sine plus that, and the derivative. Oh, no. Oh, I see. Sorry, the derivative of that is just negative 12. Oh. Okay, so I think you were right. Yeah. Here, so I'm just gonna do this again. Do this again. Hold on. So we have uh negative 12x cosine of x plus 12x sine of x minus 12, not 12x, but minus 12. That's what I got wrong. Sine of x minus 12 cosine of x. Gotcha, dude. Okay. Let's see. Wait, so are you guys also doing this as well? Okay. Let's see. So, hold on. I'm just gonna. All right. Now, okay. So I'll try what you said. I'll factor negative 12x plus sine of x. Wait, but isn't this what I had last time? Yeah, no, that's what I had last time. All right, now I'll just plug that in. All right, you have negative 12x cosine of x plus 12x sine of x minus 12 sine of x minus 12 cosine of x. 6 sine, right? Oh boy, what's going on? Negative 12 cosine of x plus 12 sine. Oh, oh no. Sorry, no, we're good. 12 sine of x. Do square? No, you don't square the x. That makes no sense. Plus, right? And that's what we got, yeah. And then we have minus 12 sine of x. Dude, minus 12 cosine of x. All right, that should be good. Yes, let's go. We got it. Okay. We got 6 problems left. Holy moly. Oh, wow. Yeah, we got 15 minutes left. So, come on. Yeah, I don't think we're going to finish 6 problems like that. Or maybe we will. But, what do you say here? So, at negative pi. Yeah, you do the quotient rule, huh? You do all that. Oh, okay, yeah. We're everything we know. Okay, so let f of x equal. Okay, let's write that down. Prime of x equals negative pi. Okay. Excuse me. Prime minus. sine of x, cosine of x. So cosine of x minus sine of x. So we have okay, pause. Okay, let's read this. Plus x sine of x. There you go. Sine of x. Sine of x. Squared plus 2 sine x cosine x. Be 2 sine of x cosine x. 2 sine of x. Identity. Sine of 2x. Yeah. So sine of 2x. So we have sine of 2x, right? Yeah. Now we have yeah, okay. I guess I'll just but evaluate it at pi. Sine of pi plus pi. Interesting, bro. Cosine of pi plus 5 pi sine of pi. Sine squared of pi plus sine of 2 pi. Sine of pi. The y. Okay. Sine of pi is -1. No, hold on. No. 0. 0 plus and cosine of pi is going to be -1. So -5 minus pi cosine pi plus sine. What is sine squared of pi though? Pi. Right. Okay. Yeah. You just square it. So 0. And cosine squared of pi. So cosine of pi is going to be -1. So -1 times -1 is 1. So 1. Sine of 2 pi is going to be, it's going to be 0 as well, right? So yeah, all over 1. Awesome, dude. Okay. So we have 5 minus, and cosine of pi, what is cosine of pi? Cosine of pi is going to be -1, -1 plus 0, -1 plus 5 pi. 5 plus 5 pi. I believe that's what we get. Oh, wait, and what's... Oh, negative pi. Oh, no. Crap. Oh, well, I mean, I think that's... that's the same thing, right? Oh no, dude, this is gonna. All right, we got 8 minutes left to finish this problem. Right. Okay, I hope this is correct. If it's not correct, I know why, but a -5. Yeah, it's good. Oh, let's go. Awesome, bro. Whew, okay. This is taking quite some time. Got it. How long do we have? We have 7 minutes left. Whew, okay, dude. Let's okay, yeah, we got all right, let's make most of our time. So we have five squared secant of x. Now 5x squared. Find f prime of x. Simplify f by using the identity. Secant. Oh, cool. Oh, yes, I remember that one. Gotcha. Cool. Okay. So, well, the quotient. Yes. No. Time. Okay, yeah. I go ahead and do it. So yeah. 10x sine cosine of x equals cosine of x. Oh. Of x cosine squared of x minus plus. No, dude, times negative plus sine squared of x over cosine squared of x. Hold on. So what does that mean? Cosine squared of x plus sine squared of x over cosine squared of x. That's what we have. Cosine squared of x plus sine squared of x over cosine squared of x. Over 1 over cosine of x. Perfect. Okay. So we're getting somewhere. Now, we're going to multiply by the reciprocal. So we got secant of x. All right, 10x secant of x. 10x secant of x plus. Oh wait, hold on. Is that times? Crap, that's times. Yeah. So not plus. Cosine of x plus sine of x over cosine squared of x times cosine of x. There you go. Now we do, so 10x secant of x. Oh, would you look at that? Cosine of x plus cosine squared of x plus sine squared of x over cosine of x. Okay, well, yeah, I believe that's good. 10x secant of x. Whoa, let's keep it PG right here, dude. Whoops, nope, there we go. Plus sine. Okay. Cosine of x. 40 secant of 4. Okay. And then we have, what's this? Yeah, what is, yeah, I don't know. So, darn it, dude. Hold on. How much time do we have? We have 3 minutes. Oh, okay. Well, let's see. What did we get wrong here? Oh, did we? Oh. Minus. Yeah. Come on, dude. Minus. And right. Okay. Minus. No, cosine squared of x. Perfect. Hold on. So we got that minus. Okay. High deal. Right. Tangent of x. High d low. Derivative of secant of x is, what is the derivative? Okay, well, what is the derivative of 1 over cosine of x? Do I have to do the quotient rule again? Okay, so the derivative of 1 over cosine of x is going to be 1. Okay, so it's going to be negative sine of x minus, no. Right, cosine of x. Oh, so 0. So it means this negative sign, negative minus high d low, high minus high d low. Okay, so that's the so sine of x. There we go. Yeah, that's simple. Wait, derivative of cosine of x is going to be this, a sine of x. Awesome. All right, so we got sine of x. And that's derivative of secant of x. Sine of x. I think so, right? Derivative of secant tangent of x. Secant of x. Hold on. Secant tangent of x. Oh boy. Are you sure? Secant tangent of x. I thought it was sine of x, but all right. Okay. Yeah, actually, what's derivative of secant of x? Quotient or chain rule. I see. Okay, secant of x times tangent of x. Hope we don't have to apply the derivative again. Secant of x times tangent of x. That's what we get. Okay. Do we have? All right. I'll finish this problem and then I believe we can be done. So 10x secant of x cosine squared of x plus sine squared of x over cosine squared of x minus 5x squared secant of x tangent squared of x. Wow, dude, this is complicated. We don't know. We don't want to do that. We just want to multiply by the reciprocal. Cosine squared of x. Perfect. All right, dude. I mean, I hope that this is correct, or else we can finish this another time. We got 10x secant of x cosine. Come on, bro. Cosine squared of x plus sine squared of x over cosine squared of x minus 5x squared times secant tangent squared of x times cosine squared of x. Whew. Okay, now we plug in 4. 40 secant of 4. 4 squared is 16. 16 times 5 is 80. 80. Okay. 80. 4. 4. I hope. Yep. Okay. All right. Well. Okay. That was a tough problem. I'll probably have to finish it later. Thank you, everyone, for joining me in the stream. That was a good 2 hours of math. And I hope you guys had fun. I'll see you guys later.